Practice A number 4, H. A 6-kilogram object moves with a velocity of 3 meters per second. It collides with the second 6-kilogram object at rest. So VB is 0 because that's what rest means. After the collision, so before we start doing anything else, we need to draw our what's happening diagram. So here's A, and it's moving along. Now, this vector is going to represent its momentum before, so that's going to be PA. And then it hits B, which is at rest. So that's before. After the collision, A moves off in a direction 50 degrees to the left of its original direction. So what I'm going to do is the original direction of ball A is my frame of reference. So I'm just going to kind of draw a dashed line to represent my frame of reference. So then after the collision, it says it moves off in a direction 50 degrees to the left of its original direction. So if this is its original direction, now it's going to go this way 50 degrees to the left. Ball B moves off in a direction 40 degrees to the right of ball A's original direction. So it says draw momentum triangle, but you also need to find, and that got cut off, I think, with a typo. So for B, you need to find PA prime, PB prime, VA prime, and VB prime. So the first thing I'm going to do is I'm going to draw my total momentum before. So this vector represents the total momentum before PA. Now I can calculate PA because PA is just MAVA. So that's going to be equal to 6 kilograms times 3 meters per second. So it's 18 kilogram meters per second. So this represents the total momentum before. Now remember, with conservation of momentum, the total momentum before is equal to the total momentum after. But these are vector quantities. So when I add them, the total before is equal to the total after. They have to be added together vectorially, which is head to tail. So this is the total before. This plus this added together is the total after. So I'll start with this represents PA prime, and this is PB prime. So this is where I start. From where I start, this is PA prime. From the head of this vector, I'm going to do the tail of the other, and this is PB prime. So that's momentum triangle. So then when I put in the angles, this is 50 degrees, and this is 40 degrees, therefore this is 90 degrees. And now, basically, I have a right triangle, and I want to first find the other two sides. So I'm not even using physics anymore, I'm just doing math. So should I use sine, cosine, tangent? It really doesn't matter. So sine's the first one I think of. So sine of theta is opposite over hypotenuse. So sine of 40 degrees is equal to PA prime over 18 kilogram meters per second. So 18 sine of 40 degrees, when I do that on my calculator, sine times 18 equals 11.57. So 11.57 kilogram meters per second is equal to PA prime. So now I want to find PB prime. There's more than one way to do it. If I have the hypotenuse of the right triangle on this other side, I could use Pythagorean theorem. I could use cosine. Or you know what? Maybe I'll use sine again. So sine is equal to opposite over hypotenuse. So sine of 50 degrees is equal to PB prime over 18. So 18 times the sine of 50 degrees, and when I do that on my calculator, 50 sine times 18 equals 13.79. So 13.79 kilogram meters per second is equal to PB prime. So now I have the momentum in A and B. Now I want to find the velocity of each after the collision. Well, what's my definition of momentum? Momentum, P, is equal to mv. So PA prime is equal to MA times VA prime. So VA prime is equal to PA prime over MA. So all I do is substitute in my values, 11.57 divided by 6, and that comes out to be 1.93 meters per second. That is VA prime. Then I do the same thing with PB. So PB prime is equal to MB. The mass doesn't change, times VB prime. So VB prime is equal to PB prime over MB. So it's 13.79 kilogram meters per second divided by 6 kilograms. So that comes out to 2.32 meters per second for VB prime. So the key to this problem is my momentum triangle. So the first thing you need to do is you need to draw your what's happening picture. So if you go back and you look at your original picture, you see that the total momentum before is equal to the momentum of A. The total momentum after is PA prime and PB prime. So because momentum is a vector quantity, this is the total momentum before, and then these two added head to tail is the total momentum after. So once you have this triangle, the problem is really, really, really simple. At that point, after you have your triangle, then you have a right triangle, you know the hypotenuse, you know all the angles, and you want to find the other two sides, so that's how you find PA prime and PB prime. See, at this point you're done with physics. This is math. The only physics that you're using is P is equal to mv. And then once I have the momentum after, then I can go back and find the velocity, again using momentum is mass times velocity, P is equal to mv. So PA prime is MA times VA prime, rearranging the equation and solving for V. And that's it. So it's all the diagrams. When we did forces, it was all about the free body diagrams. Again, even when we're doing momentum, it's all about drawing your diagram, because once you have your diagram, it's really simple, and then you're just doing that. And that's it.